everyone. Welcome to the lecture series videos of continuous process improvement. So in this lecture, we are going to discuss about continuous process improvement. Before discussing into the detail, we must know what is process. So process, it is a black box which converts one form of input into another form. So anything it converts into input into output, that we can say process. So in industry, the industry may be a service related industries like hospitals, hotels, or process related industries like manufacturing industry, production industry. So if you go for any these kind of industries, there must be a process. So we have to improve the process continuously so that we can achieve success in the business. So let us discuss in detail about the continuous process improvement in the upcoming slides. So for discussing continuous process improvement, we have a circle. That circle is called a Deming circle or a Deming cycle. So this circle was invented by Edward Deming in the year of 1915. Before invention of this circle, one more circle that is called the PDCA circle was invented by Edward Deming. So PDCA stands for Plan, Do, Study and Act. But there are some alterations was identified on those days. Then that circle again revised into PDCA circle. So the PDCA circle stands for Plan, Do, Check and Act. So this circle consists of 4 distinct stages. So the first stage is plan. So plan, so if you have any process, we have to plan for the process. So what are all the outcomes or takeaways after completion of this process? What are all the inputs needed, resources needed, and how we are going to make the conversion of input into output. So these are all the things we need to do in a planning stage. So next, do. Do means we are performing operations. Say for example, machining. So machining is a process. So to do machining, we need to calculate manpower, machine requirements, the number of quantities we are going to produce, etc. So that is under the plan stage. And do stage, we have to perform the machining operation with the available machines and manpower. Finally, we are getting some kind of outputs in the form of components. Then the third stage is check. So check, in the check stage, we have to evaluate the process outputs, whether it is conforming to the requirement or not. That can be identified with a set of instructions that is called a protocol using quality systems. In the after machining, we are getting components. So that components can be checked with the help of measuring instruments in terms of dimensions. So if the components is conforming the dimensions, then we can dispatch the component. Or otherwise, so we have to make some kind of modification. So that is there in the next stage, that is act. If the process is in line with the system, then we can we can proceed for the process. Or if there is any deviation with the system, so we have to measure the deviation and find out the root causes for the problem and take the necessary actions for the problem. So these things are there in the act stage. So after measuring components, if it is the dimensions are okay, we can dispatch in the check stage. If it is not okay, then we have to go for that stage. We have to make some necessary modifications like changing machining parameters like feed, depth of cut, etc., or provide proper training to the workers or operators in the factory, or changing the material or design of the component. So these are all the necessary steps or actions to be taken in the act stage. So the continuous process improvement, it utilizes the resources in the factory, and finally we are aiming for the high quality driven culture in the factory. So as we are already aware of that, quality is the fitness for the use, or otherwise called conforming to the requirements. So if you do any service related operations or product related operations, we need a quality in those operations. So the quality can be achieved by utilizing the available resources in the factory, and we are using that resources for the better quality improvement in the product. So this is the main theme for the continuous process improvement. So this can be achieved by uh, the following points. The first point is viewing all work as a process. So if you go for any kind of industry, it may be a product or process related industry, n number of works or operations are there. So we have to approach that work or operations in the form of process. So next step is making all process as an effective and efficient and adaptable. So we are not doing the process in a like lethargic manner. So we have to do that process in an effective manner. Finally, if you are doing a process in an effective manner, we can get an efficient process, and that can be adaptable to any operations. Then next we have to anticipate the customer needs. The customer needs is not constant for all the times. It is continuously varying. So we have to anticipate or forecast the customer needs. So that is useful for planning our work. The next stage is controlling in-process performance using measures such as scrap reduction, control charts, etc. So once we fixed it, we have to we go for the process. Then we need to measure the in-process performance using some tools and techniques to reduce the scrap. So the tools and techniques uh, may be a statistical tool, SPC, statistical process control. We have to use various control charts like X bar chart, R chart, C chart, P chart. So those charts can be used to measure the in-process performance of the process. In eliminating waste and rework. So waste and rework can be accumulated in the factory in the form when we reject the components. So we have to reduce the rejection so that the waste and rework of rejected parts can be completely eliminated, which improves the performance of the industry. Finally, we can get the succeed in the business. Eliminating non-value added activities. So if you go for any process, it has n number of steps. So many of the steps are important steps, and few of the steps are not important. So those steps we can avoid or we can bypass those steps. So those steps are called non-value added steps or non-value added activities. So we cannot get the output from those activities. So we have to completely identify and completely eliminate the non-value added activities so that we can reach our goal easily. Eliminating non-conformities. Non-conformities are nothing but rejections in the or scraps in the industries. So we are doing process in the right manner, we can eliminate the non-conformities in the process using benchmarking technique. So if you go for any operations, that process can be succeed by another uh, corporates or another companies. So we can take that steps as a benchmark, and we can set our goal above the benchmark of those things. Incorporating learned lessons in future activities. So if the parts were rejected in the component and in the industry, so we have to take necessary action, and that those actions from those actions we need to learn lessons. In future, we have to avoid those kind of problems in the industry. Finally, use technical tools such as statistical process control, benchmarking, experimental design, QFT. It stands for Quality Function Deployment. So these statistical techniques can be useful to improve the process for the stated industries. So these are all the references used for continuous process improvement. So I hope this video is useful for you. Thanks for watching the video. Thank you.